So hello everyone. Today we're going to be doing a nice little integral problem. Namely, we're going to be doing the integral of x squared over the square root of x squared plus 4 dx. Okay, so first of all, what I would like to do is rewrite x squared. Rewrite this subintegral function in a slightly more manageable manner. So over the square root of 4 times x squared over 4 plus 1 dx, which is the same as 1/2 of the integral of x squared over the square root of x over 2 squared plus 1 dx. Okay, so I'm just going to go ahead and rewrite this a little bit more. So this is the same as 1/2 of 4 times x over 2 squared, x squared over 4, okay, that's okay, over the x over 2 squared plus 1 dx, which is the same as 2 times the integral of x over 2 squared over x over 2 squared plus 1 dx. Okay, so I'm just going to go ahead and say that x over 2 is equal to tangent t, or dx over 2 is equal to dt over cosine squared t. Okay, so this will give us 4 times the integral of tangent squared t over 1 over cosine t times dt over cosine squared t, and these two will cancel out, and this gives me 4 times the integral of sine squared of t over cosine to the third power of t dt. Okay. Now, how do we go about solving this integral? Now, how do we go about solving this here integral? Well, we could go ahead and rewrite it as 4 times the integral of sine t times sine t over cosine to the third power of t dt. Okay, and what could we do from here? Well, we can get that if we say that u is equal to sine t, then du will be equal to cosine t dt, and dv is equal to sine t over cosine to the third power of t dt. Then we'll get that v is equal to what? So to do this, we first must So to do this, we first have to solve the integral of sine t over cosine to the third power of t dt. So cosine t is equal to z minus sine t is equal to dz, and dt of course here. So dt is equal to dz over minus sine t. Okay, so we'll get the integral of sine t over z to the third times dz over negative sine t. These two cancel out, and this will just give us 1 over z squared, which is the same as 1 over cosine squared of t. Okay, so v is equal to 1 over cosine squared of t, and this will now give us uv minus the integral of v du sine t over cosine squared t minus the integral of cosine t dt. Okay, and now all we are supposed to do is find the value of the integral of cosine of 1 over cosine t dt. Okay, so now I'm going to solve it right here. So the integral of 1 over cosine t dt is equal to z is equal to tangent of t over 2. So dt is equal to 2 dz over 1 plus z squared, and cosine of t from here should be equal to 1 minus z squared over 1 plus z squared. So we get the integral of 1 plus z squared over 1 minus z squared, 2 dz over 1 plus z squared. And we can, you know what, we can just include this minus right here as well. Okay, so I'll put that in there as well. So we get the integral of 2 over z squared minus 1 dz. Now let's break this apart into partial fractions. So 2 over z squared minus 1, or better yet, 2 over z minus 1 times z plus 1 is equal to a over z minus 1 plus b over z plus 1. So using the cover-up method, z is 1, 2 over 2. So from here, a is equal to 1. And from here, minus 1, well, and b is equal to minus 1. So we get that this is the same as the integral of dz over z minus 1 minus the integral of dz over z plus 1, which is the same as the ln of z minus 1 minus the ln of z plus 1, and z was tangent of t over 2. Okay, ln of tangent of t over 2 minus 1 minus ln of tangent of t over 2 plus 1. And of course, t is equal to the arctangent of x over 2, which is equal to the ln of the tangent of the arctangent of x over 2, everything over 2, minus 1, minus the ln of tangent of arctangent of x over 2, everything over 2, plus 1. So, the final answer to our problem is going to be that our starting integral of x squared over the square root of x squared plus 4 dx is equal to the sine of arctangent of x over 2, the sine of arctangent of x over 2 over cosine squared of the arctangent of x over 2 plus the ln of the absolute value of tangent of arctangent of x over 2, everything over 2, minus 1 over the tangent of arctangent of x over 2 over 2 plus 1 and plus c. So that is our final answer in this video. I hope you enjoyed it. If so, leave a thumbs up button and subscribe. And of course you could rewrite this in a more elegant way, but I really don't feel like doing that right now. So maybe try it out for exercise and let me know. If so, write down in the comments.